First of all, thanks for staying after the food. That doesn't always happen. It's much appreciated. You may have noticed a different talk title on the schedule. That's because I was supposed to do something else, then realized I only had 30 minutes, so kind of wrote another talk in the meantime. So tonight we'll be talking about dependency injection. We'll be doing a review of the state of the art. So it's just generally what dependency injection is, how people do dependency injection in Rust, how does that work, why it's good, why it sucks, and why Pavex does it slightly differently. So that's the theme of the night. Before we get into the nitty-gritty, a little bit of an introduction. My name is Luca Palmieri, and I work here at Mainmatter, as in the company, not here in the Munich office, as their principal engineering consultant. And I look specifically after the Rust side of the business. So training, strategic consulting, staff augmentation, all that stuff. Ooh, our audio is coming back to me. Let's mute this computer. Beautiful. You can find myself on the internet, mostly on my website, where I used to publish more articles, as that's the tale of every blog that people keep. I've been in the Rust community for several years at this point, wrote articles, maintain a bunch of tools, maintain a bunch of libraries. I am probably best known as the author of Zero to Production in Rust, which is a book that introduces people to backend development with Rust. Uses an hands-on approach, which is the same type of methodology that we use for this, which you found down there, which is an introduction to the Rust language in 100 exercises. Every exercise has a bunch of theory and then tries to verify your understanding. Cool. Enough. Let's get into the meat of the talk. Dependency injection. Before we go into how people do dependency injection, it's probably good to establish why we may want or not want dependency injection. For every framework under the sun, you'll find always the same promise. We'll let you spend more time working on your business logic. That's pretty much every framework. Like you can substitute your favorite language, your favorite framework, they all make the same promise, which we can convert into the negative. We try to minimize the share of time that you spend working on glue, so trying to stick together different things that may have not been designed to be stick together, or the time that you spend doing business agnostic code. Classical example might be you have an application, this application needs a dashboard, this dashboard needs authentication, you need to write an O2 social login. That's going to be the same 99.9% of the time for every single application. If you're writing it from scratch every time, you're wasting time. You want to write it once and reuse it. Even best, you want someone else to write it for you. So you want to delegate these business agnostic tasks either to the framework itself, if it comes with batteries, or to the ecosystem around the framework, if they provide the batteries. Hopefully, they kind of fit together. Nice. But you can't just delegate the whole request processing pipeline because your business logic is going to be in there. So you need to find a way to decompose this complex request processing pipeline into smaller units. And then we're going to write some of those smaller units and we're going to outsource the other half that we don't care about. Now, dependency injection is one of the ways in which you can do this decomposition and recomposition. It's not the only way. You can simply say function calls are perfect for composing and decomposing and go down that path. Notably, in the Rust ecosystem, that's the choice at Dropshot, as one of the web framework does. No middlewares, no dependency injection, just write functions like the good old days. And that's fine. Like for some applications, that's perfect. But other applications try to make it so that you can break these small units out and you can compose them in a way that's a bit more nice. At a high level, when we think of a request handler, we can model it as a function of the incoming request, so whatever's coming on the wire, as well as some kind of long-lived state. That state may live in a database, may live on disk, may live in memory. We are going to access it to know how to process the request, and we may also mutate it depending on what we're trying to do. The outcome for the caller of our API is going to be a response, so some kind of HTTP response that goes on the wire. Let's look at a fictional request handler. You may have a request that's coming in, you have your application state. To process that request, you may need to do some downstream HTTP calls. So you've got a provision HTTP client. Now, since you want to be able to debug it, you also might need some diagnostics. So you'll need a logger. Then you'll want to authenticate. So you'll need to extract the user ID. You'll have to check if it has enough permissions, for example, to do what they're trying to do. Then you do the actual thing that you want to do. And in the end, whatever is the outcome of that operation, you got to marshal back into an HTTP response. Now, we might want to say that all those subunits can be moved out of the handler. So we might want to have a handler that actually looks like this. Don't make me build the HTTP client in there. Don't make me build the logger in there. Don't make me extract the user ID. Just give them to me already done. I'm going to do the permission check, the business logic, and then convert back into the response. It goes smaller. Like the share of business logic over the total number of lines in that function is just go higher. And if you wanted to, you could take this farther. We'll see how. But generally speaking, the pattern here is that to allow that kind of signature, the framework now must have a way to look at your handler and say, what needs to be built? So what are the dependencies of this handler? And once I've identified them, how do I build them? So how do I get a logger? How do I get an HTTP client? How do I get a user ID? And the way that you usually do this, either explicitly or implicitly, it's not necessarily going through this graph step, but you look at the handler and you say, what are the inputs? A, B, C. Now, how do I build B? I need to call this function. This function itself is going to have inputs. I'm going to take them, etc., etc. This looks very simple because it's a toy handler. Reality is much more massive. It's going to have tons of nodes, tons of edges. It's not going to fit nicely into a slide. But it gives you the idea of the type of reasoning that a framework that supports dependency injection needs to be able to do. Cool. As I was saying before, we could go one step further. So we could take those preconditions that is authenticated and make it a precondition to the invocation of the handler. We could also take the marshalling out of the request handler. So we could get to something that looks like this. Handler, these are my inputs, only gets invoked if the user is authenticated. I do my business logic, I return the outcome directly. Somehow that's going to get converted into a HTTP response. This may start to feel kind of familiar if you've been doing some web dev. It's what you usually try to write in mature frameworks, so to say. Now, that's where middlewares were coming to the equation, but we only have 30 minutes, so we're not going to talk about that. What does, so we have established what dependency injection is, we have established why you may want it, and we have established what job the framework needs to make it happen. So the question now becomes, what does a great dependency injection system looks like? And here comes Luca's specific opinions. Number one, it would be ideal if when you're trying to do this dependency resolution, all mistakes, all missing dependencies, all dependencies that you don't know how to build, or circular relationships, they should be code at compile time. I don't want my users to ever, try to hit an endpoint and get a 500 back that actually under the hood is a failure to resolve one of the dependencies. And secondly, kind of bonus points, it'd be nice if the error is easy to understand. You get cookies for that. Two, we want to outsource these units to someone else. So we don't want to build that logging. We don't want to build that JSON deserialization. We don't want to build a lot of things. But we also need to compose them together into something that makes sense as a cohesive unit. To make a very specific example, if you have an API which you're offering as a service to a client, that API is going to have a schema. For example, it might be very specific as to the way errors need to be communicated back to the caller. All the errors, for example, might need to be JSON objects, which have certain fields, and those fields have to be defined. Now, if you have extractors, as we've seen before, so creating an HTTP client or trying to extract the user ID, if those fail, those errors will have to be marshaled. And we want those to be marshaled according to the schema of our product, which may or may not be the schema that whoever wrote that, crate on crates.io is using to serialize those errors. So we need to be able to tune these units a little bit so that what comes out at the end as a cohesive whole actually makes sense. So that's requirement number two. Let's review what's available. What do we have? Number one, first thing to...
We just lost the screen share, I don't know.
No. Technical problems. Yes, we have lost the screen share. Let's recover it. Consent. Screen. My browser blocked the screen. That's very ominous. Let's change browser. Oh. Spoilers. Don't look. Yes. Condividi. Sì, nice. Oof.
It's great. It's quite a journey.
Is it not? Cool. Are we good?
Yes.
Nice. Well, what happened there? Okay, where was I? Well, we stopped me just at the beginning of the second section, so it's good. So first thing to take notice of, most frameworks, most of the most popular Rust frameworks actually have dependency injection. Axiom, ActiveWeb, Poem, like the list goes on and on. These all have a kind of dependency injection system. And all these dependency injection systems are trait-based. So they work around the concept of a trait in Rust, and we'll see what that means in a second. So let's look Axiom as a reference. I'm not picking Axiom for any specific reason beyond the fact that most of you may be familiar with what that looks like. But statement is exactly the same in every other frameworks. The traits may be named different, and the types may be named different, but the system is identical. So if you want to inject something into an Axiom handler, you need to implement a trait. There's two different traits, one for stuff that looks at the body and one for stuff that looks at the head. That doesn't matter too much, it's just borrow checker details. The trait to extract from the head looks somewhat like this. I've amended a bunch of sensing things around just to make this fit nice. So you have from request parts, you're taking as input the parts of the request that's coming in. That's the version, the method, the header. That's pretty much it. You're taking the application state, so that long-lived state that you may need to refer to fetch some stuff from. As a result, you're returning self, so the implementer of this trait, the type that you want to make injectable. This extraction may fail, so you may return a rejection type, which is an associated type. The only thing that we want from the rejection is that it needs to implement into response. So if I fail to extract, that means I need to stop the pipeline, return the error to the user. To return the error to the user, I need to send something over the HTTP protocol, so it needs to be convertible into an HTTP response. Pretty simple once you remove all the trait bounds. Now, the framework relies on the Rust compiler for two things. A, to ensure that all your inputs, so all your request handler input parameters, do implement these traits. If that's not the case, the framework would reject the handler. And two, to actually resolve that method and invoke that logic. So if you're writing, this is like straight from the Axiom documentation. If you're writing a create user handler that needs to deserialize some JSON payload, which is here, if JSON didn't implement the trait from request, this registration down here would fail. So the compiler would say, this doesn't implement terrible things. You can register it as a request handler. So that satisfies the failure compile time requirement that we were discussing before. Said that, the way this works is actually extremely fascinating because you need to be able to inject variable numbers of inputs, right? But Rust doesn't have variadics, which makes this incredibly tricky. There's a very good talk from Rob Eade, which is the maintainer of ActiveWeb, which uses, as I said before, exactly the same system as to how you get traits to do this thing for you. It involves a lot of tuples. That's a spoiler. I'm not going to go in there. It would take 40 minutes, but I do recommend you checking this out if you just want to understand how Axiom or ActiveWeb do this. Said that, let's evaluate it from a user perspective. Like, we don't care about how it's implemented. Let's look at how it works. Number one, this is a big pro. The Rust compiler is all you need. There's no additional tooling. You run cargo build, dependency injection, either works or doesn't work. Number two, to learn how to use this dependency injection system, you need to learn how traits work. But that's a positive, because traits are a foundational concept in Rust. If you're doing Rust, even semi-seriously, you will have to learn how traits work. So learning to use the framework forces you to learn a concept that you'll be able to reuse elsewhere. That's a very nice learning journey. So that's nice. Obviously, there are some downsides. Otherwise, this talk would be a very short one. And the first one is that composition errors are not always caught at compile time. And let's see what that means. As I was anticipating at the beginning, dependency graphs in the wild are much wider, but most importantly, are much deeper. What that means is that a unit depends on another unit, which depends on another unit, which can be summarized as dependencies have their own dependencies, recursively. Now, if we go back to the definition of the trait, which is right here, this allows you in the request handler to inject a bunch of types. But you can't inject anything. You cannot inject anything here. And that's because if you try to implement a trait, the trait implementation must match exactly the trait definition. If to extract, let's say, the user ID, you need to have access to the session state, there's no way for you to take the session state here as an input, because that would violate the contract of the trait. Now, obviously, so trait method can accommodate recursive dependencies. Obviously, there is a solution, otherwise these frameworks wouldn't have dependency injection. And the solution, the workaround really, not a solution, is to use a type map. If we can't get things through the signature, we snuggle them back somewhere else. So every framework in Rust that has dependency injection that works with traits, at its deep, darkest core, has a type map. A type map is a hash map that is keyed by the type ID. For those of you who haven't spent a lot of time in that part of the standard library, first of all, you're very lucky. Secondly, type ID is an opaque identifier that the Rust compiler generates for any type that implements the any trait, which basically means that it doesn't have lifetimes if you really squeeze it. So a type ID is something you can ask the compiler to give you by just giving it a generic parameter with that type, or just by giving it a value. And it'll tell you type ID is a string. There's no structure to it, it's just a random identifier. There's a bit of structure, but you're not supposed to rely on it. So when you do an hash map of type ID box D in any, what you're basically saying is, I have a bunch of values of various types, and I just want to put them all in one place, and I want to be able to say, store a value with this type, and give me back a value with this other type. So you're completely losing any kind of type system structure that is deductible at compile time. Everything becomes runtime verified, so that allows you to do this thing with different types, but obviously has some cons. Before, all the relationships were actually tracked through the type system. Now, instead, rather than asking for things as parameters, the upstream nodes are inserting into the type map, and then downstream nodes query the type map at runtime to retrieve the values that they need. Going back to that session example, if you need the session state to extract the user ID, what that means is that in your extractor, you're going to get parts.extensions.get session. Now, if you were careful to actually register a middleware or a component upstream that creates the session, that works. If you forgot, that fails. Now, it's easy to find out in a small application, can be surprisingly tricky to debug in a larger application. So that's not nice. Because fundamentally, we have taken an explicit relationship, one that was clearly visible in like input parameters, and we've turned it into an implicit dependency that depends on the order in which components have been registered. The best. Now, I will settle that, so let's skip. Let's get to the second requirement, and which is the second downside. Customizing a unit when you're using trait-based dependency injection is actually surprisingly non-trivial. And that is because the trait system in Rust tries really hard not to let you do this. The whole trait system in Rust is designed to prevent ambiguity. What that means is that the compiler, for a given pair of trait and type, allows you to have either no implementation or one implementation. There can never be two. That's why you have the orphan rule. So that's why the compiler doesn't let you implement a trait defined somewhere else for a type defined somewhere else. Because if more than one person does this, then there's multiple implementations. Which one do I call? I don't know, so I will disallow that. What this means in the I terms, so if we look at the dependency injection kind of outcome, is that for the I systems that are based on traits, for a given type, there can only be one recipe. There's only one way for the framework to instantiate that type. And that's because there can only be one implementation of the trait that the framework uses to inject the type. Now, let's look at an example, JSON, just because it's a very common one. The JSON inside of Axiom implements the from request trait, so the variant that uses the body instead of the head. This is the implementation. Now, as you can see, there's a certain rejection type and there's a certain function body. Now, if I want to change the way JSON is deserialized in any way, so for example, I want to take away SERDY JSON and I want to use eSERDY to do deserialization, or I want to use a CIMD JSON deserializer, I need to create a new type. I can't change the trait body in there. That's not allowed. If you want to change the way the error is reported, for example, so if we go back to the definition, rejection here uses JSON rejection. JSON rejection will be converted into a plain string response. So you're asking your user for JSON, and if the extraction fails, you're sending back just text, no JSON. That's generally not what you want to do. So most applications in production can't use this as is. Because that wouldn't fit the scheme of a JSON API. Like you get JSON in, you send JSON out when it fails and when it succeeds. But you can't change JSON rejection. So what you need to do is you need to create a new type, call it myJSON, change the rejection type to be one rejection type that you control, implement into response for your new myCustom rejection, and then you're off to something. But the problem is that you're not done. Like you now need to make sure that everywhere in your code base, you're using your own custom extractor. Otherwise, bad errors slip through. And it gets worse than that because you also need to make sure your dependency tree is using your new extractor. So say, for example, you are importing an OAuth2 authentication flow, which defines a bunch of routes. That those routes needs to marshal JSON. They're going to use the Axiom default extractor, which means they're going to have the error you don't want. You want to fix that, you fork it. Not the best. So yeah, it's really non-trivial. Oof, that was a long run. Which brings us back to Pavex and some water. Lovely. So Pavex is a framework for building Rust APIs. It's a personal project of mine that's been going on for a couple of years. If you never heard about it, that's good. It's because it was in closed beta. It's still in beta, but now the beta is open. So if you want to try it out, you can. It's on pavex.dev. And Pavex does provide dependency injection, hence this talk, but we don't do it with traits. So we do it with a slightly different system, and we're going to look into that. And that's the time when I see it, which is good. Feels really good. So is this big enough? Yeah? Could be bigger? Okay, cool. Oh, what did I do? Okay, nice. So Pavex has many frameworks, comes with a CLI. This CLI can do things. Most importantly, it can scaffold new projects. Like the best cooking shows, I scaffolded a project beforehand and compiled it so that this is going to be fast. So you're not going to see that part. It's quite simple. I am going to start it up here. I think I had a command in my, yes, shell history. So throughout this demo, I'm going to have a cargo watch in the background that kind of recompiles the project and relaunches it every time so that hopefully you don't see too many like waiting for compilation steps. As you can see, the API emits logs in JSON format, which is quite nice. And it's going to tell us that it's running on 8,000. So just to check, we are off to a great start. Well, there's a lot of things. Just gonna ping it, returns us at 200. The logs also confirm us that we got the response. So this demo works. It's not doing anything interesting, but it works. Oh, that is small. Big, big, big. So Pavex, just like Gerask before, provides you with a bunch of things. That's hierarchical configuration, telemetry, beautiful stuff. We don't have time to discuss any of that tonight. So we'll go straight to the way dependency injection works. Pavex, like Axiom in a way, as kind of a single struct that you define things against, which is the blueprint. You define routes, you define middlewares, you define constructors, as we'll see before, and a bunch of other things. So let's create a new route. We'll call it greet, and will be at self greet get. Ooh. Beautiful. And then I'm going to create a module for it. It's not the best. Oh, the most ergonomic code writing experience. That'll do though. Nice. So we may start with something. No, I really don't want your code completion, friend. Get. Nice. Let's start with something simple. This is going to return OK. And we are missing an import. Cool. This should be recompiling, which is good. And then we are just going to check again that it works. Nice. So we get 200. So what do we want to do? I'm going to write a handler that looks somewhat like the one I showed you in the slides. So it's going to do some pre-computation, and then we're going to step-by-step extract those out, and we'll see what that looks like. We're going to do something very simple, and you really shouldn't be doing in your own applications. So we're going to use it. We're going to authorize people by checking the authorization header against an hard-coded string that's going to live in the code. Don't do this at home, disclaimer. Pavex allows you to inject things into the signature. There's some types that we call framework primitives that you can always inject because they are part of the request response pipeline, namely the request. You can always get that. Just like Axiom, we distinguish between the request head and the request body. The head is the one that has the headers. Since we want to do... Okay, that's a very valid complaint. Oh, it's fine, it's fine. I can go... So, you are the one person that always needs to exist into an audience because you'll show up there with font size 9 and you're like, can you all see down there? Yeah, sure. Nobody can see shit, but nobody will say anything. So, I will appreciate you tonight. What are we saying? Yes. So we get the request head. This will always work. From here, we can get the headers, and then, we can get the authorization header. Nice and simple.
We lost the screenshot. Sorry.
It's really painful. I don't know why this happened. Are we good?
Yes.
Nice. What was I doing? Yes. So we are extracting the... Are we fine? Okay. Okay, cool. While you were talking, I kept writing code. So what are we doing? We have the head, we're getting the header, we're checking for the authorization header. If we have it, we extract it. If we don't have it, we return an unauthorized response. And then we're going to do this awful thing when we say, if the header is not equal to a magical value, then we're going to say that you are forbidden. If you're not forbidden, then we'll just say hello world. Cool. So not something I would do for work, but I'll do for tonight. In the meantime, Cargo watched this job, so things recompiled in the back. Let's check that it works. So if we send a request to greet and we don't specify an authorization header, we're getting an unauthorized, so that is good. If we specify an authorization header which doesn't have the magic value, we get a forbidden, which is good. And if we specify, let me in, we get a 200 OK. So authorization is basic, but it does what it was supposed to do. Lovely. So imagine that you're doing this for 20 request handlers. You don't want to write it in each request handler every time because it'll be a pain to manage it. So the thing we want to do is we want to move, first and foremost, that authorization extraction outside. So we're going to define an authorization struct. Will contain another value. I'm going to show off taking a reference here, just because I can. And then we are going to say, I want to take an authorization here. Nice. And if the authorization .0 is different from letting in, then return something bad. Now, as we stand right now, this should not work, right? Like, I defined a struct which contains another value. There's no way for the framework to know how to figure out how to build me an authorization. So good framework here tells you, slap on the hand, this is not OK. And we built a good framework, apparently. So the framework tells us a compile time, very important. And this error is coming from Pavex. It's not coming from the Rust compiler, even though it may look similar. I can't find a constructor for your thingy. Like, you want an authorization. You want it as one of the inputs for get. You register that route here, and the input that you want is this. I have no idea how to build it. So if you want me to fix this for you, you either need to give me a constructor or do a bunch of other things, like take it from configuration, other options that Pavex provides. But let's take the first suggestion. Now, there's extensive docs that explain to you what register a constructor is. In a beautiful next version, they will be linked directly in the header, but we're not quite there tonight. So let's do it. Let's first and foremost define the function that actually is going to do the extraction. We're going to do it with a nice method because we like object orientation. Request add. This is going to take self. And we're going to do exactly what we were doing before. Add.headers get authorization. And here I'm going to cut a corner for now. I'm going to unwrap if the authorization header is not there. And that gives me the value. And then I need to do self value. Nice.
You could map.
I could, but that would be too fancy. And also I need to do something else that later, and the map doesn't like that. So cool. So we have a method to extract it. How do we get Pavex to know this? With a nice annotation. So we mark this with the Pavex request scoped attribute macro. This is just a shorthand for another macro, which is Pavex constructor, and then you would do here request scoped. What does request scoped means? So we're telling Pavex how to build an instance of authorization. The second question that the framework needs to answer is how many times should I build it? And there's fundamentally three answers. Build it once for the application and keep it around as long as the application runs. That's something you would do, for example, with a session store or a database pool. Request scoped. Build it once for every incoming request and keep it around for the life cycle of that request. User information, authorization information, that's all nice request scoped. Third option, transient. Build it every time I knew as I need it. That could be a logger, for example. Cool. So we told Pavex, this is a constructor. It has request scope lifecycle. And Pavex is smart enough to look at the output type and say, OK, we're building an authorization. Now, if I go back here, as you have seen, the thing is recompiled. Nice. So if I now try the let me in endpoint, it works. So my constructor is being invoked, is being used to extract the header, and is doing its job. We can see that it works for real, because if we send in a request without the authorization header, the connection drops. That's because we panicked. And we can see up here the panic message as well. So everything is captured in the logs. Let's fix that panic, shall we? Because panicking on bad user input is bad manner. So we're going to do a missing authorization right here. This becomes an OK. And this instead becomes else. Return error missing. Authorization. Cool. And missing authorization is going to be just a little struct. Lack of autocompleteness. Debug, and this needs to implement the error trait, so I'll just derive it because I'm lazy. There was no authorization. Line 12, yeah, this needs to become a let sum. Thank you. Ooh. Beautiful. There was no authorization either. OK. Now, going back to the conversation we were having before, this is like the rejection axiom. So I'm trying to extract a value. The authorization may fail. This gives me an error. That's cool. But how do I, framework, convert that error into an HTTP response? I haven't told it, which means that Pavex correctly needs to tell me off. And it's going to do it. So it's going to say that the register constructor returns a result, but it didn't specify an error handler. The error handler being the component that converts the error into an HTTP response. So if I want to fix that, where I register that, so it gives me the span, please specify an error handler. Now, an error handler, just like a constructor, is nothing special. It's just a function that returns a response. So we're going to implement it as a method. So we're going to say into response, self, and this is going to return a Pavex response. And as we were doing before, this is going to be unauthorized. And then we just need to specify here where the error handler is. For now, this requires this syntax, which is not the best. It's going to go away soon. But bear with me. Cool. So this is going to recompile. A bunch of things are going to happen. Now it runs. And if I don't pass authorization, I correctly get a 401. So the error handler is being picked up, is being invoked, but required. Lovely. Now, we could go further. We could extract this authorization out, take that check into middleware, and make this nice and tidy. But I realize I'm way over time already, so I'm going to stop right here and go back to these slides. Wrapping up, I've shown you a little bit of how DI works with Pavex. As you've seen, there are no traits. They're just methods and functions. The methods and functions need to return the things that the framework wants. Those are documented. If you forget to register a constructor, to register an error handler, if you do something wrong, the framework will catch it at compile time, and usually will give you an error that it's at least nice to look at. Most of the times it's also useful. So that is nice. Nonetheless, it's a new system. It's built on Pavex's compile time reflection engine, which means it may have some bugs here and there.
You can see on the stream.
What? Do I need to sit down? Okay. I'll sit down. Just makes me feel very small. Cool. So what I was saying, it looks cool. Obviously, in the demo, everything looks cool, but there's going to be issues here and there. So if you are interested, if this talk gave you the fancy for a different type of dependency injection engine, I do invite you to join the beta and just try it out, take it for a spin, try to break it. That's much appreciated. And any error report, I treasure deeply. Said that, that's all I had to say tonight. I hope this was interesting, and thank you for your time. Now, slouch in the chair.
Any questions?
It was the fastest end.
Sometimes procedural macros are known for increasing compile time. Do you see like big compile time for bigger projects, or is it?
No, not really. Oh yeah, repeat the question. So sometimes compile markers are known for increasing compilation times of the projects. Do you think that's going to be a problem? No. The statement that procedural macros increase compilation times for projects is one that needs to be questioned because it really depends on what the macro is doing. So procedural macros increase the compile time of a project for fundamentally two reasons. Reason number one, they may bring in dependencies that otherwise you wouldn't use. Namely, this is usually a variation of seen and quote. But they're almost always going to be in your dependency tree unless you are really not using a lot of crates. So that's generally not a big problem. The second problem is that your procedural macro will have to be compiled as a binary because the compiler needs to run it. So the penalty there really depends on how big the macro is. Third, it depends on how much work the macro is doing. If you're just parsing a bunch of Rust code, that's going to be fast. Obviously, if you're doing what Diesel does and generating hundreds or thousands of lines of code and then need to be type checked by the compiler, yeah, you're going to pay for that dearly. Now, in the case of Pavex, it's actually really nice. I don't think I have an IDE that can do this. Maybe I do. No, I don't. If I were to expand this, I can actually do the expansion by hand. This expands to this. That's the expansion. There's nothing else. What is that? This gets into the exoteric. So you may have noticed a few versions of Rust ago. This may be 6 months, 7 months. The Rust compiler introduced the diagnostic namespace. The diagnostic namespace is primarily used for library authors to provide hint to the compiler as to what diagnostic to show in specific failure modes. For example, if you have a trait in your library and you want to show a custom error message if that trait is not implemented, you would use the hashtag diagnostic on unimplemented and say, show this error if specific trait is not implemented. Now, they did something really cool with the diagnostic namespace. They left it open. So you are allowed, it's part of the spec, that you can actually register custom diagnostic for custom tools. And the compiler will just ignore these annotations. So everything you write under diagnostic will stay an attribute in the source code. This attribute Pavex is able to retrieve via rust.json. And so I'm basically able to find this function, and I'm able to parse that output in my compiler and then know what I need to look at. So really, these markers are incredibly lightweight. They're not doing anything beyond parsing, emitting this little nugget, Checking that you're even doing something crazy, like annotating a union, that's pretty much it. So in terms of compile time, penalty is minimal. You pay a much bigger compile time penalty with Pavex because we need to do compile time reflection. That part is a lot heavier. These macros are cookies in comparison. But yeah, that was a good question to ask. Nice. Yep.
So why is missing authorization into response in the error handler qualified with self? This missing authorization isn't part of it.
Self is the, so that's why it's slightly confusing. Self here is not referring to self from the method, it's referring to the module. So it's in this module, self missing authorization into response. A different way to write that would be to do create, blah, 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 but that would be much longer. In a future, which may be as soon as next week, we'll actually be able to do something different, which is we'll let you define a default error handler for a type, in which case this will go. And this will be, oh, what did I do? Cool. And this will be enough. So that's the way it's going to work in the future. Under the hood, the shoe gets to that type so that we can do our dependency resolution. But from a user perspective, you'll just be doing this. And the possibility will remain to specify them by hand if you want to change the error handler specifically for one instance of that error. But the general pattern, the way this is going to look in your code is going to be like this, which is going to make it more intuitive.
Thanks for a really nice talk.
Thank you.
Apart from it being better, what are the disadvantages over Axum, for example?
That's exactly what I was mentioning before. Oh, repeat the question. Yes. Why shouldn't we all switch to Pavex right now? I think that is what. Exactly. Well, first and foremost is in beta, which means, as I was mentioning here, right, that's not final. We're going to do it this way. We're going to do it this other way. It's not stable. Like if tomorrow you were to launch a large-scale commercial application, you wouldn't be building it on this. It's not stable enough. Stable in terms of API stable, not stable in terms of it works. This builds on many of the same components that Axum builds on. Underneath, there's Tokyo and there's Tower. There's Tokyo and there's Hyper. So it's the same kind of like deep libraries powering it all. The other reason is that this is a very opinionated, DI-heavy type of framework that some people may not like. This aims to be a batteries included framework, for example, which is very different from what Axum aims to be. You may think of Pavex much more closely to Rocket than it is to Axum. So if you were a kind of guy that looked at Rocket and Active Web and liked Rocket, then this might be a good fit. If you were still using ActiveSwap, this probably might not be your jive. In the end, like micro frameworks have a reason to exist. Axum is a very good micro framework, but just like in other ecosystems, I think there's a space for a much more heavyweight, fully featured framework. I think we're seeing different options in that space. Loco is one of the most famous ones, and there's 20 other Axum wrappers that try to fill that niche. That's the niche we're going for here. And obviously, this is weird. So it's much weirder than using the Rust constructs, which means it has a steeper learning curve. So this may be something that you care about or not. There's pros and cons of the Axum. Like if you remember during the talk when I was talking about the Rive-based dependency injection, one of the pros was this works just with the Rust compiler, and everything you need to use this is something you can use, everywhere else in the Rust ecosystem. That's not the case here. Like if you learn these macros, you'll be able to wield Pavex effectively, but not going to be able to bring this knowledge to some other library. It's very specific to using this, which is a pro and a con.
How much harder is it to contribute to Pavex than to Axum? Or put another way, if you get hit by a bus, hopefully not, is it dead?
I mean, also Axum is dead if the maintainer gets hit by a bus. So to repeat the question, what's the bus factor on this project?
How much more complicated is writing all that magic, the macros and then the reflection and all that stuff, than to that tuple-based?
No, I'll get to that. So how much more complicated is it to do this than to do the right trait-based? Much more complicated, extremely more complicated. But the good thing is that just one part of the framework. So the reflection engine is a complex part. So doing that dependency graph resolution is definitely not simple. It's a compiler. Like you are writing a compiler. So a compiler that goes from Rust code to generated Rust code. That's the way Pavex works. I haven't gotten into it, but basically the blueprint gets analyzed, and this is in the end the runtime code that you run. So this generates Rust code in lines of the definition, so you can actually look at the way the code looks like after being rendered. Oh, I opened the wrong file, did I? Cool. So it's more complex, but the reality is that that complexity in the engine then lets the Pavex runtime stuff actually be dramatically simpler. Like if you look at my JSON extractors, like you could write that tomorrow morning. It would take me 20 minutes to explain to you how to do it. So the mantra, I think, is complexity doesn't disappear, right? Like you can move it around and you can choose where you stash it. The bet here is that I'm willing to hit a lot of complexity internally so that I can expose something that looks simpler. Does that work? Depends on how much complexity leaks. So that's an open research question if we want at this stage. But yeah, that's obviously a concern. Zishan.
Can this extract method be async, or did you?
Oh yeah, it can be everything you want it to be. Like this could very much be asynchronous. Yeah, nothing would change. Oh, let me remove. Yeah, everything can be everything can be asynchronous.
I thought maybe you avoided async.
No. I avoided async because I wasn't doing any async, but no, anything can be synchronous or asynchronous. If it's asynchronous, Pavex will await it. If it's not asynchronous, Pavex will not await it. And it's the same thing of the result, right? So anything can be fallible or infallible. If it's fallible, things will behave a certain way. If it's infallible, things will behave a different way.
First off, really cool to see something nice like this done with the diagnostic namespace of attributes. I like that. And my question is, how does the F macro work in when you build it? So of course you don't have like name resolution or access to typing available in proc macros.
So how does the F macro work? How do all these macros work? That's a nice question. It's a talk of its own. So the F macro, once again, is a very simple macro. So what does it do? The IDE int is just a way to tell a Rust analyzer, this is a path, auto-completed. The real macro is down here. So what does it do? It creates a row identifier struct. In here, it says, it stringifies the path. So it stringifies exactly the thing you passed here. So that's going to be a string that is self : ping get. So far, so good. Then it records the macro name because different macros can register different things. Doesn't matter too much. And then it calls this with location macro, which is up here. And the with location macro stores that value. So the row identifiers I just showed, and then nails down a bunch of metadata. It's like, where was I invoked? In what package? What version of that package? In what module? These little breadcrumbs is what then allow me to find it.
Okay, and then you run a compile pretty much Rust driver on this.
No, I don't use Rust. I use Rust doc JSON because it's much easier, much faster than running Rust directly. So you know what you see in, so let's imagine I told you, right? There's a function called ping get in this module of this crate. How would you do it? You would go on the documentation, you would look at the module, you would find it. I do exactly the same thing, just do it with JSON. And then, you know, RustDoc contains the signatures, so I can figure out what the inputs are and what the outputs are, and it all goes from there. So very, very naive and very devious at the same time. I think there was another raise hand somewhere. Off you go.
So how do you override, for example, into response? So the thing that has
So you would just, so how do you override into response? You would just register another error handler beneath, and that would override the previous one. So if you wanted to use the extractor from Pavex and that defines an error handler you don't like, you would just register another error handler for that specific error type, and the last one would win. There's going to be another system more involved to make this more declarative so that it's easier to control, but that's what it boils down to. Since we're not using traits, you know, you are allowed to have conflicting implementations, The only thing that's important is that Pavex understands clearly what's your intent as to what is the one that you want to be using. You already asked the question, so we'll go there.
Is it possible to create this approach, implement this approach for other request response protocols? Is that something you can extract maybe at some point out of?
So is it possible to take this DI engine and make it more general purpose? I mean, to any question that starts with, is it possible? The answer is obviously yes.
It's reasonable.
The answer to is it reasonable is also yes. The point is that if you want to make a reflection engine general purpose, you need to make it so that it's going to work for all different kinds of graphs. While if you specialize it for web, that allows you to cut a shitload of corners along the way and still get something that works. So it's in my long-term goal to be able to support different deployment targets. So for example, being able to build an application as a server, as well as a bunch of Lambda functions. And that very much requires the kind of generalization you're hinting at, which is you need to be able to support different types of inputs and outputs. So it is possible, but I have no immediate plans to kind of extract this out and make it, hello, here's a DI engine, go use it. Because that will make my work 10x the size.
Am I paying any runtime penalties for these nice abstractions?
Am I paying any runtime penalties for this extraction? Absolutely not. So as I said before, all this business of resolving the dependency graph ends up with generating the runtime code. We can actually look at it. That's a nice thing of doing a code generator instead of doing a macro. Like the output is right there. So we can go down and we can see here is the router for API greet. So we're going to get a request, we're going to match it, and then it's going to go into the entry point. The entry point gets the match pattern, the request ends, then calls wrapping 0. Wrapping 0 invokes some middlewares, which I didn't show you before because they were not relevant. It invokes in particular, let me navigate it. Pipeline 2, stage 1. Here it is. Cool. So invokes mapping 1. Cool. So this is the telemetry that you were looking at in the terminal. So here, when the request comes in, we generate a server request ID that goes into a root span that contains all the information about the request. The root span is then captured as part of the state and is going to go into the next step of the pipeline. At the end, when stuff comes back from the pipeline, we're also going to log the response data. So we're going to get logging before and after. So you could go in here, and then you could go to stage 2. Stage 2 is going to invoke the handler. The handler does exactly what you would expect. So you see, we see back the shape of what we were talking about before. So the handler does the authorization extract. That's a result. It's going to match on it. If it succeeds, it's going to continue. If it doesn't succeed, it's going to handle the error by converting it into a response. It's going to log it because the default template includes error logging so that you know when stuff blows up. And then it's going to convert that into a response. If the extraction succeeded, it's going to invoke your grid get. And here, just for simplicity of code generation, into response is called for the response. That's a no-op. You just have the response. So no, there's absolutely no runtime code to hold this dependency injection situation. It's just a compile time step that's going to generate a bunch of code, and that code is going to get compiled just fine. So that's also the interesting part. Like the Pavex CLI, this code generator, is only needed to generate this server SDK crate. Once you have done the generation, you can just use the normal Rust compiler. So for example, you don't need to run Pavex in CI. You just need to run Pavex to check that the code is fresh. But other than that, you can just compile straight. So you also don't pay that extra step penalty in your continuous integration.
Other than error reporting works if my code in production panics, right? Because it refers that it's linked to this code, but not to the code that I wrote. Right? Is that, do you link that?
That's not quite how it works, because this is a dependency of your project, right? If the two things are not, so it said, how does that work in production if it fails because the two things are not aligned? That can't happen, because if the two things are not aligned, your project won't compile.
If my code in runtime just panics because I left an unwrap in my hand.
Yeah.
The code that runs is the code that generated by Pavex, not my source code.
Well, yes and no, right? So the code that runs invokes your code. So if it panics in your code, the stack trace will have your function. There will be an intermediate stack trace in there that says server SDK wrapper 75. But in the end, if it panics in extract, it panics in extract. In fact, if you look back, I don't know if I still have it because I did a bunch of stuff in the meantime. There was the panic we were looking at before, right? Oh, here it is. And you can see exactly what's happening here. And it tells me exactly when it panicked. I disabled the backtrace for now, but if I had a backtrace, that would show exactly what we're talking about. So you don't need anything that looks like a source map, if that's where your mind is going.
Right.
Are we good? Nice.
Thank you, Luca.
Thank you.